All right, guys, this lesson is on simplifying rational expressions. So the first thing we need to do is we need to define what a rational expression is. So an expression that is the ratio, so a ratio of two polynomials. That is what a rational expression is. And notice that ratio occurs in its name. It's the first part of rational. Okay, so some things to remember about this is that you're going to have a numerator and a denominator, just like a normal fraction. That's what a ratio is. It's a fraction. And that the polynomial you are dividing by cannot be 0. That's very important. Okay, so what that means is this x plus 2 cannot equal 0. So we would have to find what value doesn't work in this ratio. So in this case, it would be -2. The denominator cannot be -2. Now, in order to simplify a rational expression, the first thing we're going to do is we are going to factor. We are going to factor forever. That's all it is factoring. Both the numerator and the denominator completely. We have to factor 100%. So this means greatest common factor. This means taking out negatives if we need to. We're going to factor everything completely. Then once we have factored completely, we would divide the numerator and the denominator by their greatest common factor. And then we have to just make sure that there are no other common factors besides 1. Now, when we go about canceling out factors, so factors right here, that's important to know. This is not a term. So the difference between a factor and a term, a factor is separated by multiplication. So like this 2 times x, those are factors. 2 and x are factors. X squared, x times x are factors. They're separated by multiplication, which means that you can cancel any like factors. So notice here they divided out x over x, and then we're left with 2 over x. That is allowed. This is okay. Over here, we have x plus 3. Now, x and 3 are terms, but the entire parenthesis is a factor. X plus 4 is a factor, even though individually those are terms. So what that means is this x plus 3 here and this x plus 3 here, we're able to cancel because they are like factors, and we are left with x plus 4 over x plus 2. Okay, they have canceled those out. Now what they cannot do is you cannot say, oh, well this x over this x, those are the same, so let's cancel them. This is a no-no. The reason we cannot do this is because x plus 4 is stuck together. X plus 2 is stuck together. They are terms. We cannot cancel terms. So what I do is I put parentheses around just like I did here so that I am not tempted to cancel out x divided by x. The only way we could do this is if this was x times 4 or x times 2. But if there's a plus or a minus in between, we cannot cancel them. Okay? So now we're going to actually look at simplifying some expressions. So if you'll look here at number 1, notice it says simplify the expression and then identify any restrictions on x. So first of all, I guess we need an expression, right? So our first expression is going to be x squared plus 7x over x squared. Now, first off, we cannot cancel out this x squared and this x squared because x squared plus 7x are factors. So x squared plus 7x are terms. So I would recommend putting that entire expression in parentheses so that you are not tempted to say, oh, the answer is 7x, because that would be very, very wrong. So x squared plus 7x has parentheses. It's a married couple, as I say. It stays together. It's a family. X squared is just a term on the bottom. Now the next thing we're going to do is we're going to factor completely. So x squared plus 7x is a binomial. So in order to factor this, I would start by taking out the greatest common factor. So we'd have x, and then we'd have x plus 7 left. So the numerator is completely factored because x is a linear factor and x plus 7 is a linear factor. Now, x squared is just a term, but if we wanted to, we could break this down into x times x, because that's what x squared means. And notice x times x are factors. So now we are going to find any common factors. So we can take this x on top and this x on bottom, and they can actually cancel out. So what that means is they divide to equal 1. So when we divide them, that equals a 1. And we are left with x plus 7 over x. Now again, we cannot divide x and x. Okay, x plus 7, married couple stuck together. X on the bottom is its own thing. It's done. Now, the next thing we need to do is we need to identify any restrictions on x. Now, I actually should have done this before. I should have done it at this step here where I factored it out. And the reason being is if you don't, you may miss some restricted values. So if we look here at this x times x, the denominator, remember, cannot equal 0. So we have x and we have x. Neither of these values can equal 0. Well, that means just x can't equal 0. That is our excluded value. Now in this case, it happened to be the same thing for our simplified expression, but that's not always the case. So let's look at one that doesn't happen for. So number 2, we're going to do x squared minus 2x minus 15 over 9 minus x squared. Okay, so again, remember that the numerator, the whole thing is together, and the denominator, the whole thing is together. We cannot divide these x squareds. So again, my advice to you is to start by rewriting this with parentheses. So numerator in parentheses. Now the other thing I would do is notice this denominator is not in order. It is not in standard form. So that would be the first thing I would want to do is I would want to get, the top is already in standard form, but the bottom is not. So if we put this in standard form, we would have negative x squared plus 9. And this is going to be important to make sure that we factor things completely. Okay? So starting with the numerator, if you will recall, x squared is x times x. Negative 15 would be negative 1 times 15, or positive 1 times negative 15. Negative 3 times 5, or 3 times negative 5. So we've got to figure out which of those sets equal negative 2. So in this case, I believe it's going to be 3 and negative 5. That would add to negative 2, correct? So we would factor this as x and x plus 3 and minus 5. And it doesn't matter which order those factors come in. Now, negative x squared plus 9. The first thing we want to do is we want to remove the negative. So negative x squared minus 9. All right, that's useful. So now, again, we're going to continue factoring. So this is going to end up being x plus 3, x minus 5 on top. On bottom, we have negative. Now, that's a difference of squares. So remember, difference of squares is going to be x and x plus and minus 3 and 3. So now we're looking for common factors. So notice we have this x plus 3 and this x plus 3 on top and bottom. The entire factor can cancel out. But again, before we do this, we really want to look at those excluded values. So notice here, those excluded values, the negative, well, negative is never going to equal 0, but x plus 3 can't equal 0, and x minus 3 can't equal 0. So the values that we would not want x to be here would be negative 3 and positive 3, because if that happens, we would have our original expression would be undefined. And in order for our original expression to be equal to our simplified expression, which in this case our simplified expression is x minus 5 over, now that negative, you can leave it on bottom. I tend to put it out to the side just so that I'm not, I don't know, it's just kind of the way we do things in mathematics sometimes. We like things over to the side. So negative x minus 5 over x minus 3, and you can keep the parentheses. I would not count that wrong if you want to keep parentheses so you're not tempted to divide those x's. But here we have to include that negative 3. Even though those factors canceled out, we still have to include it in the original problem because if we don't, then our expression is not equivalent to our original expression. Okay, so they have to have the same excluded values, the same restrictions. All right, let's try number 3. So number 3 is going to be, let's do x squared plus 2x plus 4 over x cubed minus 8. All right, so some things I'm already liking here. I'm liking that it's already in standard form for both of them. Now I notice the bottom is a difference of cubes, so that's a special case. And now looking at the top, I'm looking at factors of 4. So factors of 4 would be 1 times 4 and 2 times 2. Well, when I look at factors of 1 and 4 and 2 times 2, neither of those add up to be 2x, which gives me an idea that this may not be factorable. But what we're going to do is we're going to check to see if it's factorable. So I don't know if you remember this or not, but we have something called the discriminant, and the discriminant can actually help us know if something is factorable or not. So just a reminder, we have, this is what's underneath the radical on the quadratic formula. So remember, this is A, this is B, and this is C. So B is 2, A is 1, and C is 4. So when we find the discriminant, we end up with negative 12. Negative 12 is not a perfect square. So if this value is not a perfect square, it is not factorable. Okay, so not a perfect square, it's not factorable. So that means that numerator, that lovely quadratic, simply stays as it is. There's nothing we can do with it because it is unfactorable. Now, we talked earlier that our denominator is a difference of cubes. Remember, there's a special pattern to this. So we start by saying, okay, well, this is really x cubed, and 8 is really going to be 2 cubed. 2 times 2 times 2 is 8. So we would have x minus 2. So remember, you take the perfect cube root. Then you would square x. There's a plus next because we started with a minus. X times 2 is 2x. Another plus, and 2 times 2 is 4. So that would be our factorable expressions. Now we just looked at this. Remember, this, if this pattern continued factoring, this wouldn't be the pattern. So x squared plus 2x plus 4 is not going to factor anymore, which is kind of useful because look at the numerator. Those are the same factors. But before we actually start canceling things out, let's figure out what x cannot equal. So we know that this expression right here doesn't have a real solution because of that negative 12 right there. That's a negative, that means there's an imaginary solution to that quadratic. So what that means is we're not going to have a real solution that ever makes the denominator equal to 0 for that piece, okay? But this x minus 2 has a real solution. It would be x equals 2. So 2 is the value that does not work here. That's the restriction on x. So when we're writing our answer, we're going to include that x cannot equal 2. And we're going to simply mark out these lovely expressions here. Those cancel out. There's one on the top and there's one on the bottom. So our answer, now notice there's nothing left on top. So we're going to leave a 1 as a placeholder because the fraction is still a fraction. Okay, there's 1 left, understood, 1 on top. X minus 2 is on bottom, but x cannot equal 2. So in this case, our original expression and our simplified expression shared the same restricted value. Okay, but again, sometimes the restrictions get canceled out and you have to make sure. All right, number 4. We'll let you guys try number 4. So it's 2x squared plus 10x over 3x squared plus 16x plus 5. So I'd like for you to go ahead and pause the video, try this problem, and when you're ready, turn it back on. Alright, so hopefully you're ready for the answer. So the answer is 2x over 3x plus 1. such that x cannot equal -5 or -1/3. So hopefully you've got that one correct. If not, see if you can figure out what you've done incorrectly. So I know the bottom one might have seemed a little challenging to factor, but the good thing is the first and last number are prime. So you didn't have much choice in those, so don't freak out if there's a value in front of x squared. Just write down the factors, so that's my first tip for you. Make sure you included both excluded values. There are 2. So even though the x plus 5 canceled out, it still has an excluded value that does not work. Okay? All right, go ahead and try number 5 then. Number 5, whoops, is going to be, let's do a small one. Let's do 40x plus 20 over 10x plus 30. So go ahead and pause the video when you're ready, turn it back on. Alright, so hopefully you're ready for the answer. So the answer should be 2 times 2x plus 1 over x plus 3. Now be careful here, you do not have to multiply this 2 times 2x plus 1 back. So I know some of you might have thought that you have to multiply it out. Good news is we leave it in factored form. Now the other thing is, be careful here when you divide 20 and 10. Remember, 20 divided by 10 is 2, 10 divided by 10 is 1. You don't have to put the 1 on bottom. Okay, so if you have any questions, please feel free to email me or send me a message or write a little note at the bottom so we can talk about it. But that is number 5. And I think we're going to stop there. So hopefully you understand this. If you don't, again, send me a message, write some questions down, and we'll talk about them at a later date.